Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ahmed Gharib Subhi Mahmoud. Today I'll be presenting my final year project titled Social Distancing in Classroom During Pandemic Using Machine Learning Approach. This project has been supervised by Associate Professor Dr. Rashidah. I hope you enjoy the presentation. Today's agenda will be going through the introduction, problem statement, objective, methodology, results, and finally conclusion. Introduction. As we all know, the World Health Organization has announced that COVID-19 is a world pandemic, and that the whole entire world went through a complete lockdown early 2020. As in our case from Malaysia, Malaysia initiated its lockdown on the 18th of March 2020, where the Ministry of Education has announced that it will halt face-to-face classes for both schools and universities. Now, a little bit about the virus. Now, the virus mainly is transmitted through coughing, sneezing, and close contact. And what it usually does is it mainly targets the respiratory system and it destroys it. Problem statement. Since the beginning of the pandemic, we are practicing virtual classes, which resulted in the deprivation of having the opportunity to live the full university experience. This is due to the fact that our regular classes setting is not designed for social distancing. Now, from this problem statement, we can extract three problems. Now, the first problem that we can extract from here is social distancing setting. Currently, classrooms and lecture theaters are not designed for social distancing. So therefore, classes or lectures cannot be conducted in that environment. So it has to go some sort of redesign. Number two, virtual classes. Yes, for virtual classes, we get to attend lectures, we get to attend classes, we get to learn, attend, cover the syllabus and everything. However, you cannot compare virtual class to face-to-face classes because face-to-face classes, number one, it's more engaging. You get to have a better learning experience because virtual classes, as we all experience, I myself experienced it, sometimes might have a weak internet connection. Maybe maybe it's raining, maybe you have a weak line due to overload. So you cannot compare virtual classes to face-to-face classes. And number two is that some classes require hands-on experience. For example, you have to interact with certain devices, use certain equipments, you know, maybe go to lab, you have to undergo experiments and see the results and write reports. This one you cannot do through virtual classes. Now, last but not least, the students don't get to enjoy the full university experience. Yes, I know we go to university, for the sole purpose of being educated, but university is more than that. It's a lifestyle. Students should get to discover the university architecture, the facilities it provides, and engage in activities. So, because university, it's once in a lifetime experience, and I feel like every student or every person should go through it and should experience it because it gets to shape and mold your character and who you are as an individual. Now, coming to the objectives, we have four objectives for this project. The first one is to study previous related methods and compare them. Second one is to propose a suitable algorithm to detect social distancing in classroom. Third one is to develop a system to detect safe distance between individuals. And lastly is to develop a violation announcement to remind of social distancing. Now, coming here next for the methodology, which is how everything works. First, we have the video input. Now, the video of the class is to be acquired from a class camera or recorded video and then imported into PyCharm. PyCharm is the compiler that I'm using. Second is that we have the frame separation. The video then will be separated into multiple frames such that each frame is then displayed as a single image in order to be processed in the final step. And then third, we have the person detection. Here, obviously, with the help of YOLO, the detection algorithm, each person will be bonded with a rectangular box, and algorithm is limited to only detecting people. It's programmed to only limit detecting people, so only be detecting people in this particular algorithm. And next, we have distance detection. For distance detection, it will be calculated in pixel form. So the distance between two individuals or two bounded boxes will be calculated in pixel form. Now next we have the violation detection. Now, as we said earlier, when we have two bonded boxes or two individuals, 1 meter apart or less, they're lit red as we agreed. So if they are lit red for more than 7 seconds, the reason why it's 7 seconds is to confirm that they are violating social distancing. So if once the timer hits 7 seconds or exceeds 7 seconds, then it will trigger a violation alert or more of a violation announcement. And the violation announcement says, please maintain a distance greater than 1 meter. Now this announcement will play every 7 seconds. If it, so hit the first time 7 seconds, it will alert and then it will wait for 7 seconds. If they are still violating, the announcement will trigger again, and then it will wait another 7 seconds. If they are still violating, it will trigger again. So it will keep triggering until social distancing has been observed. Now here we have the flow chart, which will give us an idea of how the system will flow. At the beginning, we have the dataset inputted, and then it will split into two. We have the video training samples, and then we have the video testing samples. Both of them will be converted into frames. And then the object here we have the object detecting model, which is pre-trained on COCO dataset, which is part of the YOLO algorithm. And then it will calculate the centroid of detected bonding box. So each bonding box has a centroid, the center, and then it will initialize the color of the bonding box, which will naturally be green. Moving up, we have to calculate the distance between each detected bonding box, which is, like I said earlier, is calculated in pixels. And then we have to define the distance threshold. And then here we have if the individual at a distance less than equal to 1 meter, if it's no, then social distance is maintained and the box will remain green. However, if it's 1 meter or less, then there is a violation, social distance violation. And what will happen here is that the system will update the color from green to red. And then here we have the confirmation. So if the box remains red for 7 seconds, then it will trigger a violation announcement. But if it doesn't, then it will just go back and see if they're still violating. But if it reaches if the timer reaches 7 seconds or exceeds it, then it will trigger a violation announcement which says please maintain a distance greater than 1 meter. And after that, it will display the number of individuals violating social distancing or violating the social distancing, and then that's it for the flowchart. Now, finally, coming to the results. So for this project, there are two testing environments. We have sample A and we have sample B. Now, as you can see, sample A here in the figure up here, the system was able to detect the students. So each student here, as you can see, is bonded by a rectangular box with a centroid. All right, and also the system was able to detect that the students are practicing or observing social distancing. So each student here, the box is labeled green, showing that they are all practicing social distancing. So therefore, the violation announcement was not triggered. However, for sample B, on the other hand, at the bottom here, as you can see demonstrated, the system was able to detect the students. However, the students were not observing social distancing. They were really close to each other. So therefore, the system successfully detected that they were not observing social distancing, and as a result, it triggered the violation announcement. Now, the next slide, I will show you a demonstration of sample B and what exactly happened. Now here in this slide, I will show a live demonstration of the system showing its full performance and capabilities. Now, as you can see here, the student is walking towards his friend. The bonded box is labeled green. Everything looks good. They're observing social distancing. And let's just see what happens. So as soon as it turns red, it will count till 7, and then it will trigger the violation announcement.
Please maintain a distance greater than 1 meter.
So here's the first violation, the first announcement. So it will only wait another 7 seconds. It will play again.
Please maintain a distance greater than 1 meter.
Now it will keep doing that until they observe social distancing. Okay, so that's it for the live demonstration. Now to conclude, the related topics to this project were discussed and compared, hence fulfilling the initial objective. The second objective was to introduce a suitable algorithm using machine learning and detection algorithm to tackle the challenges faced by the earlier projects. This one has been achieved. The third objective was to develop a system that detects a safe distance between individuals, which was successfully demonstrated earlier. And finally, to develop a violation announcement system that reminds individuals to observe social distancing, fulfilling objective number 4. Now, with this, we can also conclude that we are able to create a social distancing friendly environment. We have the resources and tools to encourage institutions and students to return back to campus and resume face-to-face classes. And last but not least, giving the students the opportunity to indulge in the campus life and to do activities, to play sports, to enjoy all the facilities that the university has to offer. Become a student who's not only educated, but a student who's also active, who's social, and basically enjoy this once in a lifetime experience because you're not gonna be a student forever, right? So yeah, with this I conclude my presentation. I hope you really enjoyed it. Assalamu alaikum wa rahmatullahi wa barakatuh.